Example 7.1, we'll look at the rotating blades of a helicopter. So let's say that these blades are 2 meters long and they have a rotation rate of 320 revolutions per minute. Now, we usually express angular speed or angular velocity in units of radians per second. In physics, we usually do that. But in everyday life, it's common when talking about rotation rates to express them in revolutions per minute. So, first question we're going to ask about this helicopter is, what's that rotation rate? What's that angular velocity in our physics units of radians per second? So part A here is a unit conversion problem. We have 320, or 3.2 times 10 to the 2 revolutions per minute. We want to turn that into radians per second. So when we say revolution, we mean that the blades are going one time around a circle. So that is 2 pi radians in one revolution. And of course, 1 minute is 60 seconds. So we find that the angular speed of the helicopter blades is 33.5 radians per second. You've probably seen some other quantities in daily life that are measured in RPM. In your car, it tells you the rate at which the pistons are moving in your engine in RPM. It's a few thousand RPM. That's usually a little easier to understand than radians per second. We don't usually have a lot of intuition for what radians per second means, but those are the units we use in physics. Okay, so how much arc length is traced out in 300 seconds? So, meaning these blades are spinning around a bunch of times. If you look at the edge of the circle, which is going to overlap by many spins, what's the total length of that circumference, or the many circumferences in 3 seconds? So we can find the angular displacement, which is angular speed times time, and then get the arc length as r times angular displacement. That's just the kind of the definition of radians right there. So plug in 2 meters, 33.5 radians per second, and 300 seconds. And those blades trace out 2.02 times 10 to the 4 meters. Question C. What's the average angular velocity if the blades rotate 26 times in 3.6 seconds? Well, the average angular velocity is the change in angle over time. That's kind of the same equation that we used in linear quantities. The average velocity is change in position divided by time. And that change in angle, well, it's 26 revolutions times 2 pi radians per revolution. So I did a quick little unit conversion there. And the time was 3.6 seconds. And that's going to give you 45 radians per second, the average angular velocity.